According to NEC 2002 Section 110.22a, identification of equipment grounding conductors. Conductors of the equipment grounding conductor system shall be readily identifiable. Section 408.4a, General, states conductors and equipment required to be grounded by this article shall be connected to equipment grounding conductors. The interpretation of these sections suggests that permanent markers, such as Sharpies, can be used to identify equipment grounding conductors if they meet specific criteria. These criteria revolve around the marking being readily identifiable and permanent. Readily identifiable means the marking must be clear, conspicuous, and durable. Markers that use bright colors or contrasting colors, such as green or yellow on a white conductor, are generally considered readily identifiable. Permanent means the marking must be resistant to fading, abrasion, and other environmental conditions. Sharpies are designed to be permanent and typically meet this requirement. Therefore, Sharpies can be used to comply with NEC 2002 Sections 110.22 and 408.4, provided that the marking meets the requirements of being readily identifiable and permanent. It is important to note that local codes and regulations may have additional requirements for the identification of equipment grounding conductors. It is always advisable to consult with local authorities to ensure full compliance. Ensuring a safe electrical installation relies heavily on proper grounding and identification. Equipment grounding conductors, often bare or green insulated, provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers and fuses. Accurate identification of these conductors is critical for safety and proper system function. Section 110.22 of the National Electrical Code focuses on ensuring that all equipment grounding conductors are easily recognizable. This helps electricians and maintenance personnel quickly distinguish them from other conductors, minimizing the risk of accidental contact with energized parts or incorrect wiring. The wording readily identifiable is key. It means that the identification method must be obvious and durable under normal operating conditions. This eliminates ambiguity and ensures that the marking will remain legible over time. Section 408.4 reinforces the importance of grounding within panel boards and other electrical enclosures. It mandates that all conductors and equipment requiring grounding must be connected to properly sized equipment grounding conductors. This connection ensures that any fault current will be safely directed back to the source, minimizing the risk of electric shock and fire. When considering the use of permanent markers like Sharpies for identifying equipment grounding conductors, several factors must be taken into account. Firstly, the color of the marking is important. While Sharpies are available in various colors, green is the color typically associated with equipment grounding conductors in North America. However, using a green Sharpie to mark a bare conductor is impractical. Instead, electricians often use colored tape or pre-printed labels specifically designed for conductor identification. If a bare conductor needs to be identified and colored tape or labels aren't available, using a Sharpie of a contrasting color, such as yellow or orange, can be acceptable, provided that the marking is clear and unambiguous. Secondly, the durability of the marking is crucial. Sharpies are known for their permanent ink, which resists fading and smearing under normal conditions. However, in harsh environments where conductors may be exposed to moisture, chemicals, or abrasion, the Sharpie marking may deteriorate over time. In such cases, it may be necessary to use more robust identification methods such as heat shrink tubing with printed labels or engraved tags. Thirdly, the clarity of the marking is essential. The marking must be easily visible and legible, even in low light conditions. A small, faint Sharpie marking may not meet the readily identifiable requirement of the NEC. It is important to use a bold, clear marking that can be easily seen from a reasonable distance. Furthermore, the marking should indicate the purpose of the conductor, such as equipment ground or grounding electroconductor. Fourthly, local codes and regulations may impose additional requirements for the identification of equipment grounding conductors. Some jurisdictions may require the use of specific colors or labeling methods, while others may prohibit the use of permanent markers altogether. It is always advisable to consult with local electrical inspectors or authorities to ensure compliance with all applicable codes and regulations. Finally, it is important to note that the NEC does not explicitly prohibit the use of permanent markers for identifying equipment grounding conductors. However, it does establish the general requirements for readily identifiable and durable markings. The decision of whether or not to use Sharpies ultimately rests with the electrician or electrical contractor, who must ensure that the chosen method meets the requirements of the NEC and all applicable local codes. In summary, Sharpies can be used to identify equipment grounding conductors if the following conditions are met. 1. The marking is clear, conspicuous, and durable. 2. The color of the marking is appropriate and does not create confusion. 3. The marking is resistant to fading, abrasion, and other environmental conditions. 4. The marking complies with all applicable local codes and regulations. However, in harsh environments or where specific identification methods are required, more robust solutions may be necessary. Proper identification of equipment grounding conductors is essential for electrical safety and compliance. By following the guidelines outlined in the NEC and consulting with local authorities, electricians can ensure that electrical systems are properly grounded and protected. The purpose of grounding in electrical systems is multifaceted, primarily revolving around safety and proper equipment operation. Grounding ensures a lower impedance path for fault currents, which facilitates the quick operation of overcurrent protection devices like circuit breakers or fuses. This rapid response minimizes the duration of fault conditions, reducing the risk of electrical shock, fire, and equipment damage. There are several types of grounding, including system grounding and equipment grounding. System grounding connects the neutral point of a power source, such as a transformer or generator, to Earth. This establishes a stable voltage reference and helps to limit voltage surges caused by lightning or switching operations. Equipment grounding, on the other hand, connects the non-current carrying metal parts of electrical equipment, such as enclosures and raceways, to ground. This prevents these parts from becoming energized in the event of an insulation failure, thereby protecting personnel from electric shock. The NEC provides detailed requirements for grounding and bonding in electrical systems. Grounding electrode systems, for example, must be installed according to specific rules, including the types of electrodes that are permitted and their installation methods. Common grounding electrodes include ground rods, ground plates, metal underground water pipes, and concrete encased electrodes. Bonding refers to the process of connecting all metal parts of an electrical system together to create a continuous electrical path. This ensures that all metal parts are at the same electrical potential, minimizing the risk of voltage differences that could cause shock hazards. Bonding is particularly important in areas where multiple electrical systems are interconnected, such as in commercial or industrial buildings. The size of grounding and bonding conductors is also critical. The NEC provides tables that specify the minimum size of these conductors, based on the size of the overcurrent protection device protecting the circuit. Using undersized grounding or bonding conductors can compromise the effectiveness of the grounding system and increase the risk of electrical shock or fire. Proper grounding and bonding are essential for electrical safety and compliance with the NEC. By following the guidelines outlined in the code and consulting with qualified electrical professionals, you can ensure that electrical systems are properly grounded and protected. Furthermore, regular inspection and maintenance of grounding systems are important to ensure their continued effectiveness. Grounding connections should be checked periodically for corrosion or damage, and any necessary repairs should be made promptly. In addition to safety, grounding also plays a role in ensuring the proper operation of sensitive electronic equipment. Electronic devices are often susceptible to voltage fluctuations and electrical noise, which can cause malfunctions or damage. Grounding provides a stable voltage reference and helps to reduce the effects of electrical noise, improving the reliability of electronic equipment. In conclusion, grounding is a critical aspect of electrical system design and installation. It protects people and property from electrical hazards, ensures the proper operation of electrical equipment, and improves the reliability of electronic devices. Adhering to the NEC requirements for grounding and bonding is essential for electrical safety and compliance. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is published by the National Fire Protection Association (NFPA) and is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is not a law itself, but it is widely adopted by state and local governments as the basis for their electrical codes. Compliance with the NEC is essential for ensuring the safety of electrical systems and protecting people and property from electrical hazards. The NEC covers a wide range of topics related to electrical installations, including wiring methods, overcurrent protection, grounding, bonding, equipment installation, and special occupancies. It provides detailed requirements for the selection, installation, and maintenance of electrical equipment and systems. One of the key principles of the NEC is to ensure that electrical systems are installed in a safe and workmanlike manner. This means that electrical work must be performed by qualified individuals who are knowledgeable about the NEC and have the necessary skills and experience to perform the work safely. The NEC also emphasizes the importance of using approved electrical equipment. Approved equipment is equipment that has been tested and listed by a recognized testing laboratory, such as Underwriters Laboratories UL or Intertek ETL. Listed equipment has been found to meet certain safety standards and is suitable for its intended use. The NEC also provides specific requirements for different types of electrical installations. For example, there are separate chapters in the NEC that address wiring methods for residential, commercial, and industrial buildings. There are also specific requirements for hazardous locations, such as areas where flammable gases or vapors are present. The NEC is a complex and detailed document, and it is essential for electricians, electrical contractors, and other electrical professionals to have a thorough understanding of its requirements. The NEC is not intended to be a design manual, but it provides the minimum requirements for safe electrical installations. It is the responsibility of the designer to ensure that the electrical system meets the specific needs of the application and complies with all applicable codes and regulations. The NEC is updated every 3 years, and it is important for electrical professionals to stay up to date with the latest changes. The NFPA offers training courses and publications to help electrical professionals understand and comply with the NEC. In addition to the NEC, there may be other codes and regulations that apply to electrical installations. These may include state or local electrical codes, building codes, and fire codes. It is important to be aware of all applicable codes and regulations and to ensure that electrical installations comply with these requirements. The NEC is a valuable resource for ensuring the safety of electrical systems. By following the guidelines outlined in the NEC and consulting with qualified electrical professionals, you can help to prevent electrical accidents and protect people and property from electrical hazards. The NEC also addresses the installation and maintenance of electrical equipment in special occupancies such as healthcare facilities, data centers, and industrial plants. These occupancies often have unique electrical requirements due to the nature of their operations. For example, healthcare facilities require special grounding and wiring systems to protect patients and staff from electrical shock hazards. Data centers require reliable power systems and cooling systems to ensure the continuous operation of critical equipment. Industrial plants may have hazardous locations where flammable gases or vapors are present, requiring the use of explosion-proof electrical equipment. The NEC also covers the installation of renewable energy systems such as solar photovoltaic PV systems and wind turbines. These systems require special wiring methods and safety devices to ensure their safe operation. The NEC provides detailed requirements for the interconnection of renewable energy systems to the electrical grid. In addition to the technical requirements, the NEC also addresses the administrative aspects of electrical installations. It specifies the requirements for electrical permits, inspections, and testing. It also outlines the qualifications and licensing requirements for electricians and electrical contractors. The NEC is a comprehensive and evolving document that reflects the latest advancements in electrical technology and safety practices. By staying up to date with the NEC and following its guidelines, electrical professionals can help to ensure the safety and reliability of electrical systems. The grounding electrode conductor is a critical component of the grounding system, connecting the equipment grounding system and the grounded conductor, usually the neutral, to the grounding electrode. The grounding electrode conductor ensures a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protective devices. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, or the equivalent for separately derived systems. NEC Table 250.66 provides guidance on the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The grounding electrode conductor must be securely connected to the grounding electrode using approved methods such as exothermic welding, listed pressure connectors, or clamps. The connection must be accessible for inspection and testing. The grounding electrode conductor must be protected from physical damage. If the grounding electrode conductor is exposed to physical damage, it must be enclosed in rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, or cable armor. The grounding electrode conductor must be continuous and without splices or joints. If a splice or joint is unavoidable, it must be made using an irreversible compression connector or by exothermic welding. The material of the grounding electrode conductor must be copper, aluminum, or copper-clad aluminum. The grounding electrode conductor must be installed in accordance with NEC Section 250.64. which provides specific requirements for the routing and support of the conductor. The grounding electrode conductor must be run in a straight line as practicable and must be securely fastened to the surface on which it is installed. The grounding electrode conductor must be protected from corrosion. If the grounding electrode conductor is installed in a corrosive environment, it must be protected by a suitable coating or by using a corrosion-resistant material. The grounding electrode conductor must be identified. The grounding electrode conductor must be marked with the word ground or grounding or with a green color. The marking must be visible and legible. The grounding electrode conductor is a vital part of the grounding system, providing a safe path for fault current to return to the source. Proper installation and maintenance of the grounding electrode conductor are essential for electrical safety. The requirements for the grounding electrode conductor are detailed in NEC Article 250, which provides comprehensive guidance on grounding and bonding. Consulting with a qualified electrical professional is recommended to ensure proper installation and compliance with the NEC. The equipment grounding conductor is another essential component of the grounding system, providing a low impedance path for fault current to return to the source from the non-current carrying metal parts of electrical equipment. The equipment grounding conductor connects the metal enclosures of equipment, such as motors, appliances, and lighting fixtures, to the grounding system. The equipment grounding conductor ensures that these metal parts are at ground potential, minimizing the risk of electric shock if a fault occurs. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. NEC Table 250.122 provides guidance on the minimum size of the equipment grounding conductor based on the size of the overcurrent protective device. The equipment grounding conductor must be securely connected to the metal enclosure of the equipment and to the grounding system using approved methods such as listed pressure connectors or clamps. The connection must be accessible for inspection and testing. The equipment grounding conductor must be continuous and without splices or joints. If a splice or joint is unavoidable, it must be made using an irreversible compression connector or by exothermic welding. The material of the equipment grounding conductor must be copper, aluminum, or copper-clad aluminum. The equipment grounding conductor must be installed in accordance with NEC Section 250.130, which provides specific requirements for the routing and support of the conductor. The equipment grounding conductor must be run with the circuit conductors in the same raceway cable or cord. This ensures that the impedance of the grounding path is minimized. The equipment grounding conductor must be protected from physical damage. If the equipment grounding conductor is exposed to physical damage, it must be enclosed in rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, or cable armor. The equipment grounding conductor must be identified. The equipment grounding conductor must be marked with the word ground or grounding or with a green color. The marking must be visible and legible. The equipment grounding conductor is a critical part of the grounding system, providing a safe path for fault current to return to the source from the non-current carrying metal parts of electrical equipment. Proper installation and maintenance of the equipment grounding conductor are essential for electrical safety. The requirements for the equipment grounding conductor are detailed in NEC Article 250, which provides comprehensive guidance on grounding and bonding. Consulting with a qualified electrical professional is recommended to ensure proper installation and compliance with the NEC. Understanding and applying these concepts correctly is essential for ensuring electrical safety and compliance with the National Electrical Code. Always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when working on electrical systems.